So hello dear students, now I have a new question and this would be the concluding video of the chapter number 14 coordinate geometry. So let's do the question number first here. Prove that the points a comma 0, 0 comma b and 1 comma 1 are collinear if 1 by a plus 1 by b equals to 1. So means these 3 points would be collinear if this condition is being applied there. So let's first check whether these points, how these points are collinear. Okay, so to show these 3 points, whether these 3 points are collinear or non-collinear, we have a method for that. That is, we are to find out the area of the triangle. If the area of the triangle is coming out to be 0, then you would call these 3 points as collinear points. Remember this? Yes, in the previous video we have already discussed about it. Okay, so to prove whether the given points are collinear or not, you would find out the area of the triangle. If the area of the triangle is coming out to be 0, then you would call these points as collinear points. Okay, so here in this case also we would find out the the area of the triangle. So to find out the area of the triangle, we need to find out x1, y1, x2, y2, x3, y3. Okay, so let me write. This would be x1, this would be y1, this would be x2, y2. Similarly here x3 and y3. Now we have the points x1. Sorry, I am writing here downside, not visual upside. So this would be x1, y1, this would be x2, y2, and this one is x3 and y3. So these are the given points. Okay, now using these given points, I have to find out the area of triangle. Area of triangle is equals to how much? 1 by 2 into x1 inside the bracket y2 minus y3. x1 y2 minus y. So x1 is a, y2 minus y3 means b minus 1, plus x2. x2 is 0 inside the bracket y3 minus y1. x1 y2 minus y3, x2 y3 minus y1 means 1 minus 0. Similarly you have x3. x3 is what here? x3 is 1, and inside the bracket y1 minus y2. x3 inside the bracket y1 minus y2. What is y1? 0. What is y2? Minus b. Okay, now let's see. 1 by 2. Okay, now if I multiply it upside, so it would be ab minus a. This would become 0 because 0 is multiplying from outside, so only this one would left here. So 1 0 is 0. 0 minus b is minus b. 0 minus b is minus b, so minus b into 1 minus b. Are you getting this? ab minus a1 ja a. This would become 0. Now here 0 minus b is minus b into 1 minus b. Okay, now here you can see 1 by 2 into ab minus. If I take minus sign common here, so it would become plus there, so it would be a plus b. Now if this a plus b is ab, this a plus b is equals to ab, then this complete would become 0, and then in that case area of triangle is coming out to be 0. Then in that case you can say yes, these points are collinear. We have been given a condition here. Let's see this condition. What is this condition? Will be equals to 0. Now look here, 1 by 2 into ab minus, if this a plus b becomes ab, if this a plus b becomes ab, then the area of the triangle would be 0 because ab minus ab would become 0. So condition is what? Condition is a plus b should be equals to ab. You have been given the condition here. If I am writing here, if 1 by a plus 1 by b equals to 1. Okay, so look here, if I cross multiply it, so it would be b1 ja b plus a1 ja a. Okay, b1 ja b plus a1 ja a means a plus b. I can write here, I can write it implies a plus b divided by ab equals to 1. Can I write it like this? b1 ja b plus a1 ja a. So means a plus b divided by ab equals to a. This ab would multiply there, would become ab there. So I can write here, it implies a plus b equals to ab1 ja ab. So this is the condition now. If a plus b becomes ab, means 1 by a plus 1 by b equals to 1. Condition has been given to you now. If 1 by a plus 1 by equals to 1, it implies a plus b equals to ab. This is coming out. Okay, so if a plus b equals to ab, then this area of the triangle would become 0. So you can say yes, these points are collinear if this condition is applied here. So you will say hence, let me write it here. Hence, if this is not visible here, let me write it downside. A plus b would be equals to ab. Okay, yeah. So yes, these points are collinear. You write here. Hence, a comma 0, 0 comma b, and 1 comma 1 are collinear if 1 by a plus 1 by b equals to 1. Okay, if 1 by a plus 1 by b equals to 1, it implies a plus b equals to ab. So this value of a plus b equals to ab, just I would put here. So answer would become 0. Then in that case you can say yes, these given points are collinear because area is coming out to be 0. But if a plus b is not equals to ab, then the area would not be equals to 0. Then in that case these points are not collinear points. Okay, so write down this. Would be doing the next thing. Now I have a new question for you. Question is, if a not equals to b and not equals to c, prove that the points a comma a square, b comma b square, and c comma c square can never be collinear. Okay, so these points can never be collinear if a and b and c are not equal to each other. Okay, so let's see. So to prove the first let's say these points are collinear. If these points are collinear, then the area of the triangle would be 0. Are you getting this? So to show that whether these 3 points are collinear or not collinear, we would find out the area of the triangle first. Okay, so I am just finding out here area of triangle is how much? 1 by 2 into x1 y2 minus y3. So let me find out x1 y1, all these x1, this y1, this would be x2 y2, and this would be x3 y3. Okay, so first one here 1 by 2 into x1, first comes x1, so x1 is a, inside y2 minus y3, so y2 is b square, y3 is c square, so would be b square minus c square, plus then comes x2, x2 is b, then there comes x2, inside what would be there? Y3 minus y1, y3 is c square, y1 is a square, means c square minus a square, plus then comes x3, x3 is c, then inside y1 minus y2 means a square minus b square. So let's find it out. 1 by 2, just multiply inside ab square minus ac square, similarly bc square minus ba square, bc square minus ba square, plus ca square minus cb square. Can you cut anything here? ac square, nothing you can cut here. Now if you see, if this all becomes 0, then the given points would be collinear. So how this complete would become 0? It would become 0 if and only if a and b and c all are equal. Look here, if a, b, c all are equal, then you can write this as like a b. So in place of a also you can write b, because a, b, c all are equal. So this would be b cube, this would be c cube. Yes or not? This would be b cube, and this is also b cube, b cube, b cube. All can be b cube then, or you can cut. Are you getting this? Yes. So here I am writing. This complete would become 0 is equals to 0. This complete would become 0 if a is equals to b is equals to c. See here, if a, b, c all become equal, then every function you can, everything you can write as a in terms of a. Right here, you can write this b also a. So a square into a would be a cube. Look here, minus this c also you can write a. So this also a cube, a square into a, this again would be a cube. This both you can write a, so a into a square, again you can write a cube, minus this both you can write a, so a square into a would be a cube, plus similarly here a square into a cube. Similarly both you can write a, So a square into a would be a cube. You can cut everything here. This so would become 0. So this is coming out to be 0 if a, b, c all become equal. Okay. If a, b, c all are equal, then these points are collinear. If this case is not being satisfied here, then these 3 points can never be collinear. That is the question is being asked. If a, b, c are not equal, a is not equals to b and b is not equals to c, then you can say these and these 3 points can never be collinear. Can these points be collinear? No, because a, b, c are not equal here. If these 3 points are not equal, then this complete would not become 0. Then the area would not be coming out to be 0. Then you can say yes, these points are not collinear. If yes, if this condition is satisfied here, then you can say yes, these points are collinear. So hence you can say hence the given a square, hence here I am writing hence if a not equals to b not equals to c, this condition is satisfied here, so this would not become 0 and these points are not collinear. Hence if this condition is satisfied, then the given points can never be collinear. Hence proof. This you have to prove. We have proved this. Okay. So note it down. Now the next question is, for what value of a points this and this are collinear? Means you have to find out the value of a, and you have been given that yes, these points are collinear. It is given there. Look, for what value of a points this are collinear, means these points are collinear, means the area of the triangle is 0 here. It has been given there, but you have to find out the value of a here. Okay, let's see how to find out. Since I am writing here, since the given points are collinear, it implies what? It implies area of triangle would be 0. So area of triangle is what? 1 by 2 into. So let me write out here first x1 y1, x1 y1, x2 y2, then this would be x3 y3. So first comes x1, x1 is a, x1 then inside y2 minus y3 means minus 1 minus 4. Second x2 is 1, then inside y3 minus y1 is 4 minus 1. Similarly you have next is x3 here, x3 is 11, inside y1 minus y2 means y1 is 1 minus y2 is minus 1, so this would become plus 1. Okay, is equals to 0 because the points are collinear, so area would be 0 here. Are you getting? You have to learn this formula for finding out the area of the triangle. So let's see, this 1 by 2 would become 0 there because it is multiplying here. This 1 by 2 is multiplying here, would go there and would become 0. So no need to write here 1 by 2, it would become 0 here. Okay. Now if you see minus 1 minus 4 minus 5 and minus 5 into a minus 5a. Let me write it here. Similarly 4 minus 1 is 3 and 3 1 ja 3 would be plus 3. Getting? Similarly here 1 plus 1 is 2 and 2 11 ja 22 plus 22 would be equals to 0. This 1 by 2 has become 0 there. Okay. Now it implies you need the value of a, so this minus 5a would go there, would become plus 5a is equals to 3 and 22 would remain here and 22 plus 3 would become 25. Are you getting this? Minus 5 is going there, would become there plus 5a. 3 plus 23 would remain here, would become plus 25. I have written it here. Now this 5 is multiplying here, would divide there. I need the value of a, so a would be equals to 25 by 5. It implies a is equals to 5. So you have the value of a that you have to find out. Okay. So this is how you would find out the value of a. Just note it down. Now I have a new question here. Question is, prove that the points this and this a comma b, a1 comma b1 and a minus a1 comma b minus b1 are collinear if this is the condition a b1 equals to a1 b. This condition is being satisfied if this condition is being satisfied, then you can say yes, these points are collinear. Okay, so now we have to find out the area of the triangle. If the area of the triangle is coming out to be 0 by applying this condition, then you can say yes, these points are collinear for this condition only. Okay, so let's find out the area of the triangle. Area of triangle is what? 1 by 2 into, first let's write here x1 y1, x1 y1, x2 y2, this would be x3 and y3. So x1 comes first, x1 is a, inside the bracket y2 minus y3, so y2 is b1 minus y3, y3 is b minus b1, so this b would become minus b and this minus b1 would become plus b1. Are you getting this? x1 inside the bracket y2 minus y3, so y2 is b1 minus y3, y3 is this complete is y3, so this minus would multiply there inside, so this would become minus b and this minus would become plus b1. Are you getting this? Very good, very good. Okay, plus then comes x2. x2 is what? a1. Then inside the bracket what would be there? y3 minus y1. Okay, so y3 is b minus b1 minus y1. y1 is what? y1 is b. Okay, plus x3. x3 is what here? a minus a1. This is x3. a minus a1. Then what would be inside the bracket? Inside the bracket is y1 minus y2. y1 is b minus y2. y2 is b minus b1. Are you getting this? Hope you are getting this now. Now what to do? We would be multiplying this now. Would be 1 by 2 into. Now look here. If you can see. Here it was x1 outside, inside there was y2 minus y3. So y2 was b1 minus y3 was minus b plus b1. Okay. If you are adding this, this would become a into b1 plus b1 would be twice of b1 minus b. b1 b1 2b1 minus b plus this b and this b can cancel each other. Would be now what is left now? a1 into b1. a1 into b1, a1 b1 and sign is minus into plus minus sign. This would be minus sign. Look here. Plus into minus minus, a1 into b1, a1 b1. Okay. Similarly here. Now here also we would multiply. First we would multiply these both by a, then again these both by minus a1. Okay. So first we would be multiplying both b minus b1 by a. So first multiply by a. So a into b would be ab. Now this a would multiply b1. So a into b1, ab1. Sign would be minus. Getting this? Look here. A into b, ab. Then a into b1. This a would multiply both, na? A into b, ab minus a into b1, ab1. I have multiplied. Okay. Now this minus a1 would multiply both. Getting? So minus a1 into b minus a1b. Then minus a1 into minus b1, minus into minus plus a1 into b1 would be a1 b1. Getting this? Very good. Now look here. 1 by 2 into. This a would multiply inside now. A into 2b1 would be 2ab1. 2ab1 minus a into b would be ab. Similarly here a1 b1 plus ab minus ab1 minus a1b plus a1 b1. Anything you can cut here? Yes, a1 b1 you can cut. ab, this you also can cut. Now nothing is left. Yes, we have the answer now. 2ab1 minus ab1. How much is left? 2ab1. How many ab1 here? 2ab1 minus ab1 would be ab1 only. Look here. Here ab1 how many? 2. Here ab1 1. So 2 minus 1 is 1, na? So 2ab1 minus ab1 would be ab1. Okay, now what is left? Minus a1b. Now C. Can I write here 0? I cannot write here 0. If, yes, I can write here 0 if AB1 and A1B both are equal. If AB1 equals to A1B, then I can write here this complete, because both become equal, then the answer would be 0. So the condition is what here? If AB1 equals to A1B. If AB1 equals to A1B, then I can write the area of the triangle is 0. This is the condition. So that was the question. Question was, prove that these points are collinear if this condition AB1 equals to AB. Yes, these 3 points will be collinear if AB1 is equals to A1. We have verified it. Okay, so you can write here, hence the given points are collinear if what? AB1 equals to A1B. This condition is satisfied. If this condition is being satisfied here, then you would say yes, these points are collinear points. Okay, so with this we are going to conclude this chapter, that is chapter number 14, coordinate geometry. Okay, now from the next we would be discussing the next chapter of your mathematics. Till then, stay tuned, keep watching. Thank you, have a good day.